Alright, let's continue these notes on this next video. Alright, we have some definitions we need to cover now. An asymptote is a line of a graph that a rational function approaches but never actually touches. That's misleading. Let's disregard this part here. Or we can leave it if we're referring to vertical asymptotes. So vertical asymptotes, it never touches. Horizontal and oblique, which are diagonal asymptotes, if you will, they can cross. All right. If a function is not defined when x is equal to a, then either there is an asymptote or a hole in the graph. All right, a hole in the graph we'll discuss in further later sections, which I'll upload for summer work if you wish to continue this course. Topics that we did not cover in this course. So basically, when the bottom is equal to 0, you have a vertical asymptote unless the factor that creates that 0 can cancel. So I'll show you real quick, and then you get a hole in the graph there. I'll show you real quick what I mean. However, I don't think we're going to cover that in this section. You'll see it in later sections. So it's a 3. So in this case, your domain, x cannot be 3, x cannot be 4, since that makes the denominator 0. But these would cancel out. Since those cancel, when x is 3, you would actually have a hole in the graph. And you have to plug in 3 into the simplified function to find the y-coordinate of that hole. When x is 4, that is where you would have the vertical asymptote, which again is a line that the graph gets infinitely closer to, but never crosses for vertical asymptotes. So the bottom is 0, it's either a hole or an asymptote. A hole if the factor that gives you that 0 cancels out. Alright, what else do we have? Are there any asymptotes for the above graphs? Yes, they both had vertical and horizontal asymptotes. What are the equations for them? So x equal to 0, that was the vertical asymptote. Y equal to 0 was the horizontal asymptote. And those describe lines. X equal to 0 is a vertical line overlapping the y-axis. Y equal to 0 is a horizontal line overlapping the x-axis. How are the asymptotes related to the excluded values we found when we solved the rational equations? Well, your vertical asymptotes will be related to them. So those are related. Which it'll be the value that's where the line is, unless again it's a hole in the graph because the factor counts it out. All right, and real quick, for holes in the graphs, you have to find the y-coordinate as well. So it's not just x3, it's 3 comma something. To get that y value, you would plug in 3 into the simplified one, and in this case, you would get -1. Graphing it, you would literally put a hole right there. So your graph will do whatever it's doing, who knows, and there's a hole right there. Calculators show gaps when you zoom in and have the scale properly, the window properly scaled. All right, so that's those definitions. It's getting a little sloppy, I do apologize for that. So given 1 over x as a parent function, and then 1 over x squared as another parent function, we can do transformations to these, just like we have any other function. So we multiply by a, so it's a times 1. That'll be a vertical dilation, so it'll stretch it vertically by a factor of a. If you subtract h from the x, so you don't need parentheses because it's in the denominator, but you can put them. So that's as if we go back to absolute value, it would be inside that, or any other parent function. The radical, so it would be in there. It's not the case. Subtracting from the x would be a horizontal translation, sending it forward, adding will send it backwards. Any changes on the x will be a horizontal transformation, having the opposite effect then you would assume minus sends it forward in this case. Adding on the outside sends it up. Subtracting would send it down. So absolute value, we had plus k on the outside, plus k on the outside for the radical one from way back when. There's one more transformation we're not going to cover at this point. It's kind of hard to tell the dilations on rational functions. But if you multiply by b here and here, it'll be a horizontal dilation by a factor of 1 over b, which we've covered for other parent functions. So let's look at this guy, number 1. So it's just going to be the parent function that we previously had, but we're going to shift it left 3 units. So your parent function had a horizontal asymptote there, vertical asymptote there, and the parent function did something like this. Domain, all reals except 0, range, all reals except 0. But we're going to shift this guy. So we're going to go left 3 units. So that's going to move the vertical asymptote 3 units. So my new graph will be right there. Oh, it should be a solid line. Let me go ahead and make it a solid line. The dashed lines are reserved for our asymptotes. So you can make a table and do a whole bunch of values and plot as needed. The instructions here, whoops. Without a calculator or a table, use one specific point, draw the asymptotes. So our domain is all x's except -3. You put -3 there, you end up dividing by 0. That is bad. That's where we have a vertical asymptote. My range, all y values will be hit except 0. So the horizontal asymptote did not change. If you wanted a few more points, use at least one specific point for each branch. All right, let's go ahead and do that. So let's pick an x that's on the right side of my vertical asymptote. Let's pick -1. So we end up with 1/2. -1, 1/2. And let's pick one on the other side. So -2, -3. Let's go with -4 right there. Plug that in. -4 plus 3 is -1. 1 divided by -1 is -1. So that's there. My graph's done really poorly, guys, but it's there. You can make the table for more accuracy. All right, example 2. Alrighty, so what do we got here? Example 2. And 1 over x minus 4 squared. So we're going to shift this guy forward. Our domain, the bottom cannot be 0. So it's not obvious. And sometimes it's not going to be. You set it equal to 0. Just your denominator and you solve it. So we will square root both sides. X minus 4 is equal to 0. Want it to be. So x cannot be 4. So that's my domain. And that is also going to be where our vertical asymptote is. Our range, we did not shift upward or downward. There's no k value. It'll be plus 0 out here. There was no k value moving it around. So our horizontal asymptote will still be y equal to 0. That goes with your range. So we can have all y values or 0, except 0, I'm sorry. So you'll never get 0 for a y coordinate. If we want to make a table, we can do a handful of points for accuracy. Let me do that first so my graphs go through them. So there will be a branch of the graph on the left and on the right of my vertical asymptote. My vertical asymptote is this line, y equal to 4. Horizontal asymptote, x equal to 0. As we get further, you'll be asked to list all this information: domain, range, asymptotes, and intercepts, holes, and then graph it. Any other points that you choose that you feel are necessary. All right, so let's pick 3. Just going to pick a number on the left side of 4 and one on the right side of the 4. So I have points on both branches. If I pick 3, so 3 minus 4 is -1, squared is 1, 1 over 1, I get 3, 1. I'll just say we're right there. You can do more points as needed, but that's the general behavior of the graph. Plug in 5, 5 minus 4 is 1. Oh, 1 squared is 1, you're still going to get 1. So 5, 1. And here's the other part of the graph. So it approaches this vertical asymptote, getting closer and closer as x gets closer to 4. And then as x gets really large to infinity and really small at negative infinity, the y-coordinates approach 0, approaching your horizontal asymptotes. And that's number 2.